Last time we illustrated the concept of conditional probability with some newspaper subscription data here. We calculated some probability, including the conditional probability down here that we knew that a person subscribed to the daily paper, they subscribed to the Sunday. And we also saw a fundamental relationship between conditional probability and the joint probability. In particular, we saw that the probability that if a person obtained the Sunday paper and the daily paper, this was just going to be equal to the probability that they subscribe to the daily paper times the conditional probability that they subscribe to the Sunday paper given they subscribe to the daily paper. In other words, if we wanted to find the fraction of subscribers to both, we could look at the fraction that subscribe to the daily and then dissect that further to look among the daily subscribers to see which portion subscribe to the Sunday. Now, it's useful to rewrite this condition to identify the conditional probability. So, for example, we could rewrite this as the probability of Sunday subscribers given daily is equal to the joint probability of Sunday and daily divided by the probability of a daily. And assuming that we perhaps didn't know this calculation directly from the table, we could easily then calculate this. You see the probability of Sunday and daily we saw was 100 over 400, and that would be divided by the probability of a daily subscriber, which was 160 over 400. And then you can notice that they have 400 in the denominator would cancel and leave us just 100 over 160, and that's what we came out with as the conditional probability here. Now, with this concept of conditional probability, we can introduce an important idea, namely that of independence. So if we have two events E and F here, we say E and F are independent. And what does that mean? In particular, we might be interested in whether or not households that subscribe to the Sunday paper and the daily paper are independent. Well, if we look at this, we could say, well, to say that E and F are independent means that, say, E does not influence F. So the probability of F is going to be the same whether or not we know E or not. In other words, the probability of F would have to be the same as the probability of F even if we knew E. So the test is, we'll say E and F are independent if these two probabilities are the same. So how does that work out for our particular example here? Is the daily subscription independent from Sunday? Okay, well, we would look at these two calculations. What's the probability of a Sunday? Well, that was 60%. So the probability up here, the probability of Sunday was 0.6. The probability of Sunday given the household was a daily subscriber turned out to be what? We saw that was 0.625, and these numbers are different. So what that would mean is that these two events are not independent. Since this probability is higher, what it really means to the company is that there is a greater chance that a person would subscribe to the Sunday paper if they already subscribe to the daily than not. Now, let's see if we can take a look at another example where, in fact, we see independence. All right, so let's, for example, take a look at a deck of cards or something like that. And let's look at an experiment where we draw a card from a deck, and we would like to know what's the probability of getting an ace. Probably ace. Well, how do we calculate that? Well, we can see if we have our various suits of cards here, 4 suits. There's going to be an ace in each one, so the probability of ace would be 4 out of 52. Now, what if in the selection of this card, the card was turned over and put face down or something, and we happen to see that it was going to be red? Okay, how does that change the probability? In other words, the fact that we know the card is red, does that give us a better chance of getting an ace or not? In other words, we want to compare the probability of an ace with the probability that it's going to be an ace given that it's red. Well, okay, so how can we figure that out? Well, uh, two of these decks, two of these suits are going to be reds, namely the hearts and the diamonds. Okay, and so of the reds, there's actually going to be 2 aces from among what? If we're just restricting ourselves to the reds, there's going to be 26 cards. So notice that the fraction 2 over 26 is exactly the same as the fraction of 4 over 52. These two quantities are equal, and what that means in practical terms is that you don't get any advantage in terms of the probability of selecting an ace if you happen to know the card was going to be red. Okay, so in this case, the obtaining an ace and having a card red are independent. In the other case where we were looking at newspaper subscribers here, we saw that Sunday and being a Sunday subscriber and a daily subscriber were not independent.